In the previous lesson, we've got a taste of the LiveView's magic. In this lesson, we are going to see how LiveView really works and what happens behind the scenes when a user connects. Let's start with a simplified version of our dashboard, a view that renders only the Coinbase BTC USD trades. So we have a simple template where we print just the product, traded at, which is the date time, price, and volume. By calling IO inspect self in both mount and render, we'll see when these callbacks are called and what is the process ID. Let's also comment these 3 lines. So this function is not called in mount subscribe to trade. In this way, we'll not get any trade update, so we can better focus just on the first part of the LiveView's life cycle. So let's start by doing a simple HTTP GET request to our live route. And we can use a tool like curl. So I start the server and then can do curl HTTP localhost 4000. So this is a HTTP GET request. And we immediately notice that the app answers to our HTTP GET request with a fully rendered HTML page. This means that we can support clients that do not necessarily run JavaScript, which makes LiveView also great for SEO. And we see in the terminal that mount is called and render is called. Let's see what happens. First, we make an HTTP GET request, and then mount is called to initialize the data to be rendered. Then render is called, which returns the render content. So far, so good. Let's now take a browser. So we open the page, localhost 4000, and if we watch the terminal, we see that mount and render are called 2 times. Let's see why. First, the browser makes a simple HTTP GET request and gets the HTML from the server. So if we see the page source, we see the render content. And then we see a meta tag here, CSRF token, and a script tag, which loads the app.js application JavaScript. So running the script, the browser connects to the server, opening a WebSocket connection, passing the CSRF token rendered in the meta tag in the header. So once connected, the server starts a stateful LiveView process and calls for the second time mount and render, pushing the new render page via the WebSocket connection. This new stateful LiveView process runs as long as the user stays connected, keeping the state in memory, listening to the events from the browser, and sending the re-rendered changes to the browser every time we update the socket assigns values. To better understand what happens over the WebSocket connection, we can use the browser inspector to see the exchanged messages. So let's take the browser, let's inspect. So going under network, if we refresh, we see first here localhost, we see the GET request with the fully rendered page, then the browser connects, loads the JavaScript, and the JavaScript opens a WebSocket connection. This WebSocket connection here. And here we see the messages. So once the WebSocket connection is established, the browser sends a Phoenix join message and LiveView replies with the Phoenix reply message containing the rendered view. So inside here, we don't find just a simple HTML. We see the dynamic values and the static parts of our template. So the static parts are kept into the browser memory, and only the dynamic changes are sent from LiveView to the browser. To render this view, the LiveView JavaScript code running on the browser simply interpolates the dynamic values with the static parts. So it takes first product 0 here, element 0, then this string Coinbase, then this string, then BTC/USD, then traded at, and then the element number 2 here, etc. Okay, but what about updates? So let's see what happens when the assigns change. We uncomment this part, so we subscribe 2 trades. In this way, we will receive new trade messages and we will assign this new trade to the socket. So we update the assigns in the socket. The view gets re-rendered and the changes are pushed to the browser. So let's add a log also here, inspect, self, label, new trade. We now have all the elements to understand why we use this if condition, socket connect. So socket connect is false during the initial HTTP GET request. In this case, we don't want to subscribe to get new trades because the process is not meant to live after the response. When the browser connects through a WebSocket to a stateful LiveView, this socket connect is true, and it's now time to subscribe the process to the pub subtopic. Let's refresh here. We see that our view gets updated, and let's inspect. So we see the join message, the reply message, and then we see this diff messages. These are the updates sent, the changes sent from LiveView to the browser. So we see this time that there is no static part. So the message, the payload is super compact. We have the traded at date time and the volume are changed. So LiveView is able to track the changes and send only the changed values to the browser. So we see here in the reply that we have the element numbers. So here, so the exchange name is the element, the first element, number 0, the currency pair is number 1. So date time is number 2, price is 3, and 4 is the volume. So here in the diff, we see that we have the same number. Obviously, LiveView uses this number to understand what it needs to update in the front end. So 2 is the date time and 4 is the volume. So let's go a little bit further. So here again, just the volume, the price is the same. We should see. Okay, in this case, also the price changed. And so we have a different volume. The volume changed. Obviously, the date time changed and the price changed. So the JavaScript LiveView code running in the browser, every time it receives updates from the LiveView process running on the server applies these changes using a library called morphdom. So in the terminal, we see that for each new trade, the view is re-rendered and the changes are pushed to the browser. We also see that the LiveView process which serves our browser is always the same. It's a single stateful LiveView process that keeps its state in memory and tracks the changes as long as we stay connected. Let's quickly recap. Our browser initially connects to the server, making a simple HTTP GET request to the live route. The server calls mount and render callbacks to initialize the data and answer with a fully rendered HTML page. The browser loads the HTML and the application JavaScript in app.js, which connects via WebSocket to the server. Once connected, the server spawns a stateful LiveView process which stays alive as long as we are connected. In mount, the LiveView process subscribes to get trade messages. The browser sends a Phoenix join message and LiveView answers with a Phoenix reply message in which there is the rendered view with dynamic parts and the static parts. Each dynamic part has a position. Every time the LiveView process receives a new trade from PubSub, it assigns in handle info callback, it assigns the new trade to the socket, and LiveView re-renders the view calling render. Only the dynamic values that change are sent to the browser with the diff message. In this way, the payload stays super compact. The LiveView.js code running in the browser takes these values, these new values, and their positions to patch the DOM using the morphdom library. And we can see, always using the inspector, that how the DOM is patched. So at the moment, this view is passive. It only receives new values from the server without any user interaction. In the coming lessons, we'll see how to send events from the browser to the server using buttons, bindings, and forms.